question 1.1.1, we are asked to solve for x. So the first step we're going to do is we're going to factorize this problem here. So we're going to say x into 3x minus 4. So we are finding the factors of x squared, which is x. Then we factor it out, we equate to 0. So the solution here will be x being equal to 0, which is this 0 here, or 3x minus 4 is equal to 0. Then you transpose the minus 4 to the other side, we have 3x is equal to 4. Divide by 3 both sides, we have x is equal to 4 over 3. So the solutions for this problem here is x is equal to 0 or x is equal to 4 over 3. Now going to 1.1.2, we are also solved for x, but we are given a hint that our answer must be correct to 2 decimal places. So what you're going to do is whenever you are given the statement, it tells you that you cannot factorize this problem. So you're going to use your quadratic formula. So minus b plus or minus b squared minus 4ac divided by 2a. Our b in this case is 10, so it's going to be x is equals to minus into 10 plus or minus the root of, you write your 10 inside, squared minus 4. Our a, it's 3, and then our c, it's minus 4. Then you divide everything by 2 multiplied by 3, which is your a. Then the solutions that you're going to get once you simplify is minus 3.69. So this is 9, or x is equals to 0.36. So these are your 2 solutions that you're going to find once you substitute everything inside. So remember that we must write correct to 2 decimal places. Now 1.1.3, we're going to solve for x for this one using the inequality sign there. So we're going to first transpose the 9x to the power squared to the other side. So we're going to have minus 9x squared plus 15x minus 4 less than 0. Then from here we're going to divide by negative. Divide by negative 1, divide by negative 1. We want to write the standard form properly. So we're going to have 9x squared minus 15x plus 4, because when you divide an inequality with a minus, the inequality sign changes. So this one was facing that direction. We divided it with a minus sign, it changes into a greater than. So it's going to be greater than 0. Then from here we are going to factorize greater than 0. So you're going to find the factors of 9x squared, which is 3x and 3x there. And then we're going to look for factors such that they will give us the middle term, which is 15. So by putting 4 here and 1 there. So those are going to be the factors. When you multiply 4 with 3, 4 times 3 gives you 12. So if you add this 12 with the 3, it will give you 15. So those are the factors. Then you put a negative here and a negative here because the sign in the middle term is negative. So the bigger sign takes that sign. So you have that your factors. Then you write your critical values. Your critical values, why? Because we having an inequality sign here. So the critical value is going to be 3x is equals to 1 or 3x is equals to 4. Then you divide by 3 both sides. You divide by 3 here. You have x is equals to 1 over 3 or x is equals to 4 over 3. So these are going to be your critical values for the problem here. So now what you need to do is you need to draw your number line. So let me draw my number line at the top where I'm going to introduce my or write down rather my critical values. So we have x being equals to 1 over 3 here, and then we have x being equals to 4 over 3. So these are my critical values, these ones. So this step now, because we want to conclude the values of x, we want to write the solutions of x. So for us to write the solutions of x, we need to go to this number line and test our number line. So what we can do is this. We're going to test values that are less than 1 over 3, this critical value here, which you can just say because 1 over 3 is 0.3333. So you can test -1 for an example, and then you test a value that is in between 1 over 3 and 4 over 3. You can say 1 because 1 is less than 4 over 3, your critical value. Then here you can test 3. So you need to test these values that I've circled, these values here. You have to test them for you to conclude your solutions of x. So what you're going to do is you have your equation, you have your standard form of equation, this one here. So you're going to write it wherever you want to write it, in your piece of paper, minus 15x plus 4. Then you're going to test. You say when x is equals to -1. So let's say we test this one here. So when x is equals to -1, you substitute. You're going to say 9 into -1 squared minus 15 minus 1 plus 4. So what we're mostly interested in here, we're not really interested in the solution, but we are interested in the sign that you're going to get when you substitute this value. So the sign that you're going to get when you substitute any value that is less than 1 over 3, which in this case we chose -1, you're going to get a positive sign. That is the sign. You can test any value. You can test -3, -4. You can test any value. It will give you a positive sign. So that value will be positive. Then you write that sign here. So you're going to write, so between 1 over 3 and -1, you know your sign is positive. All the values in between are positive. Actually, values that are going in that direction are positive. Then you do the same thing. You say, when x is equals to 1 now, because we are testing these ones. These ones that I've circled are the ones that we are testing. So we're testing 1 now. So you're going to substitute 1 in your original equation of 9x squared minus 15x plus 4. You're going to test. You're going to say 9, substitute. You put your 1 there, squared minus 15, put 1 plus 4. The solution that you're going to get when you substitute this value, you're going to get a solution of negative. Once you get that solution, you're going to go there in between your critical values, because 1 lies in between the critical value of 1 over 3 and the critical value of 4 over 3. So you're going to write the sign that you got, which is negative. You write it down, and then you continue. You test a value that is greater than 4 over 3. You say, if x is equal to 3, so we are using the circled ones, then you substitute 3. So 9 into, you put 3, where there's x, you put 3 plus 4. You only check the sign. What is the sign of the answer you're getting? You're going to get a positive sign. Then you take that sign, because you know that this value is greater than 4 over 3. So it's positive. So we know that from here to that direction is positive. From the critical value to that direction is positive. But what does the question want? Now you go back to the question. What does the question want? You know, you need to interpret the question. The question says that find values of x such that your solutions must be greater than 0. Why am I saying this? Here, just here. This inequality here says greater than, and it says greater than this 0 here. So you must find solutions such that they are greater than 0. When something is greater than 0, which means the sign is positive. We are more interested in solutions of x that are positive. So when we look at our timeline that we just did, you can see the direction of positive solutions of x. It's from this critical value going to that direction. You're going to get positive solutions of x. And then from this critical value going that direction, you're going to get positive solutions of x. So as I was explaining, when something is greater than 0, it is positive. So So this problem wants solutions of x that will give you a positive solution of y, basically. So meaning this is where you get positive solutions of y. This is where you get positive solutions of y. What are those values of x when you get those positive solutions of y? So you're going to conclude and say, therefore, when x is less than 1 over 3, when this x value, use the critical values to conclude. When x is less than 1 over 3, you are getting positive solutions of y. When x is less than 1 over 3. When x is greater, this time around, this one, when x is greater than 4 over 3, you're getting positive solutions of y. Or x greater than 4 over 3. You're getting positive solutions of y. So that's how you solve this inequality problem. So now we are going to do 1.1.4. We are having SATs. So this is solve for x but with SATs. So whenever you have a problem that wants you to solve for x with SATs, you should know that the solution at the end, you need to test it and see if it is correct, it is valid. So please note that. So we're having root of x squared minus 5 equals 2 root of x. So the first step we're going to do here is we're going to square both sides. So you square both sides, and then you have x squared minus 5 equals 2. So this squared will multiply any power that it finds inside. Any power that it finds. So you're going to have 2 to the power of 2 multiplied by x. So this x, this square root of x, is x to the power 1 over 2 like this. Then it's going to multiply by this 2, which is just going to be x. So you're going to have 2 to the power of 2x like that. If you write it properly, it's x squared minus 5 is equals to 4x. Right? Then you're going to write your problem in standard form. So it's x squared minus 4x. You transpose the 4 to the other side. Minus 5 is equals to 0. Then you have your standard form. Now you need to solve your x. So it's now simple. You find the factors of x squared, which is x and x. Find the factors of 5 such that they give you the middle term. So it's 5 and 1. And the 5 must be negative and the 1 must be positive. Then you say x plus 1 is equal to 0. Or x minus 5 is equal to 0. Then x is equal to minus 1. Or x is equal to 5. So you need to test these solutions of x because you're having a SAT problem. So you need to test your solutions of x. So I did test my solutions of x. When you substitute, so you're having a root of x squared minus 5. When you test on the left hand side, when you put negative 1 here, because we're having the solutions of negative 1, you square it, then you say minus 5. What you're going to get here, it's going to be positive 1 minus 5, which is equals to the root of minus 4. So a root that has the negative sign inside, it's just doesn't exist, right? It's not real, right? So there's no solution for this one. So hence you're going to say it's not equals to minus 1. I mean, you can still put it inside this right hand side. The right hand side, you have 2 root of x, of which 2 root of your x is negative 1. So the same thing happens on the right hand side. So the left hand side is not equals to, the left hand side is not equals to the right hand side. Hence this x is not equals to minus 1. Then you're going to test this 5 and you'll find that it's correct, but please test it and see if it is a solution of x. 1.2, we are asked to solve for x and y in this problem here. So they've really simplified it nicely for us, and please note that the marks, it's actually 3 marks. So when you check the marks, they tell you on how much you need to solve the problem, so it becomes easier to tell. So we're having this problem here and we're asked to solve for x and y. If you think about it, normally you'd have x maybe plus 1, x minus 1, for example, equals to 0. Well, how do you solve for x in this problem? You just say x plus 1 is equals to 0, or x minus 1 is equals to 0, right? Then you transpose x equals to minus 1, or x is equals to 1. So that's how you normally solve this problem. So the same concept you apply it here. So meaning that what's inside is going to be equals to this 0 here. What's inside the brackets, the squared brackets. So it's going to be 3x minus y is equals to 0, or x minus 5 is equals to 0. Then you transpose the y to the other side, you have 3x is equals to y, or x is equals to 5. So x is equals to 5, but what is the solution of y? We don't know, so we need to substitute x here. So you're going to say y is equals to 3 into 5. Therefore, it's 15. So the solution of y is 15. So that's how you solve for x and y in this problem here. Then now we want to solve 1.3. We are given this expression here, and we are told that whenever we see x minus 2, we must put y. So it's equals to y. So in 1.3.1 says that show that the given equation can be expressed in this form. So we know that y is equals to x minus 2, and the given expression is x minus 2 equals to minus 4 over x minus 2 minus 4. So we know that y is equals to x minus 2. So meaning instead of writing this x minus 2, I'm going to write y equals to minus 4 over y minus 4, right? Then we're going to multiply out this y throughout, multiply out this y throughout. So when you multiply out here, y multiplied by y is going to be y squared equals to minus 4 minus 4y. So we have to write this in standard form. So meaning you're going to take everything to the other side of the equation. So which means we're going to have y squared plus 4y. So it's plus 4y plus 4. So to write it properly, you have y squared plus 4y plus 4. So that's how we're going to do it. So now we are done with 1.3.1. You're going to 1.3.2. Hence, show that the equation has real and equal roots. So for us to do this problem, you must know your nature of roots. Nature of roots. Your nature of roots, if you have a discriminant that is less than 0, you know that is non-real. If you have a discriminant that is greater than 0 and is a perfect square, then you know your roots are real, rational, and unequal. If you have a discriminant that is greater than 0 and it is not a perfect square, then your roots are real, irrational, and unequal. If you have a discriminant that is equals to 0, then your roots are real, equal. They'll definitely be rational because they can be expressed as a fraction. So these are the nature of your roots. This is what you need to know for you to solve such problems. So here we are asked to show that the equation has real roots. Which equation? This one that we just found, that it has real and equal roots. So which expression should we use? We can use this expression here, this one, because the discriminant is equal to 0. When the discriminant is equal to 0, we have real solutions and we have equal solutions. So let's use that discriminant. It's going to be discriminant is equal to 0. We know, but the discriminant is equals to b squared minus 4ac. So what is our b in this case? It's this 4. So it's going to be 4 all squared minus 4 into our a is 1. Here it's 1. Our c is 4, which is this one here. So then you're going to have 16 here minus 16, right? Because it's 4 squared. It's going to give you 16 minus 4 times 4 is 16. So it's going to give you 0. So this is the solution of your discriminant. It's 0. Therefore, your your roots are going to be what? Are going to be real and equal. So that's how we solve this problem here. Now we're going to solve 1.4, which says that calculate the maximum value of s if s is equals to this expression here, right? So we're having s equals to 6 over x squared plus 2. So for this expression, the entire expression to be a maximum, which means the denominator must be less. So what do I mean by that? If you have 1 over 2 and 1 over 4, which one is bigger? Which expression is bigger? This expression is bigger because the denominator is smaller, right? And the denominator here is larger. So the larger the denominator, the smaller the expression, right? So our aim in this problem, it is to make the expression, the denominator rather, to be smaller for us to have a larger expression of s. So if you look, so how can we make this expression smaller? You need to look at which values of x can you substitute in this x squared. If you substitute x is equals to -1, or if you substitute x is equals to 0, or if you substitute x is equals to 1, I'm just testing these values. You can substitute any value you want. You can substitute x equals to 3, x equals to 4, any value. But remember that we want the denominator to be smaller so that we can get a larger value of s. So we want the largest value. We don't want just the large value of s. The largest value of s that we can possibly get. So if, let's say, for example, I try x is equals to -1, right? So s would be equals to 6 over 1, -1, sorry, squared plus 2. So the value I'm going to get is 6 over, so this -1 squared is going to be 1 plus 2, meaning it's going to be 6 over 3. So the denominator is 3 for x is equals to -1. Let me test for x is equals to 0, right? So s is equals to 6 over, it's going to be 0 squared plus 2. So meaning our expression is 6 over 2. So the denominator is 2, it's small. Let me test for x is equals to 1, right? So it's going to be s is equals to 6 over 1 all squared plus 2. So it's going to be 6 over 3 basically. So the denominator, so which denominator is smaller between these three x values that I've just tested? It's this x value. The denominator is 2. That is the smallest denominator. These ones are larger. It's 3, it's 3. So you can see that for me to get a maximum value of s, I need to substitute with the lowest or the smallest value of x to get the largest value of s. So our solution here is going to be s is equals to 6 over, so instead of substituting -1 or 1 or 3 or 4 or whatever value, you're going to substitute 0 because it's going to give you the smallest denominator. Hope I was clear. If I wasn't clear, please comment down in my comments section below and ask questions. I will answer you. So it's going to be 6 divided by 2 basic. So that's going to be a solution of s, which we know 6 divided by 2 is 3. So this is the maximum value that you can get in this problem here. So that is how we're going to solve this 1.4. Thank you.
Thank you so much for.
So now we are having question 2. So the first part of question 2, which is 2.1.1, we are asked to find the 5th term. So the quadratic pattern here has 4 terms, which is 1, 9, 25, and 49. So we are asked to find the other number there. So for us to find it, you're just going to write your sequence 1, 9, 25, 49, and then we don't know the next term. So what you're going to do is you're going to find a difference between these given numbers. So you're going to say 9 minus 1, you're going to get 8. 25 minus 9, you're going to get 16. 49 minus 25, you're going to get 24. and you know that, okay, this is going to be the first difference of your quadratic, and your quadratic pattern, your quadratic number pattern has a constant second difference. So our second difference in this case is going to be 8. So we know that this 8 is just going to continue just like that. So what you're going to do is you're going to add, you're going to say, okay, fine, 24, this 24 here plus this 8 is going to give me a sequence here, a number of the sequence here, which is 32. Then this 32, you're going to add it with this 49. So you're going to say 49 plus 32, you're going to get a number here, which is 81. So to get the next term, you just do that. How you say, if you add this 25 and this 24, you're going to get 29. If you add this 9 and this 16, you're going to get 25. So that's how I found this 81 here. I said 49 plus 32 gives me 81. So now we are solving 2.1.2. We say that we must show that the nth term of this sequence can be written as this follows. So we are given the nth term, but basically we need to calculate the nth term. We need to find the nth term and prove that it is actually written like this. So the first step we're going to do is we're going to still write our sequence, which is 1, 9, 25, and 49. And we found 81 in our 2.1.1 question. So the first difference that we got here was 8, 16, 24, and 32. And the second difference that we got is 8, 8, 8. So this second difference is equal to 2a. Second difference. That's the first step that we need to do. 2a is equals to 8. Divide by 2 both sides. Our a is equals to 4. So that is the first one. Then 3a plus b is equals to the first term of the first difference. Not just any term, but the first term of the first difference. So we know our a is 4, so it's going to be 3 into 4 plus b is equal to, so what's the first term of our first difference? So this is our first difference. What is the first term? It is 8. So we're going to write that 8 there. Then you transpose this the other side. Your b, you should get minus 4. That is going to be your b. Then to find your c, it's going to be a plus b plus c equals to the first term of your sequence. So you have your a, which we found as 4. You have your b, which is minus 4, plus c is equal to, what is our first term? It's 1. That is our first term. So c is going to be equal to 1 because these two will cancel out. So this, your c is going to be like this. So why are we finding a, b, and c? It's because this is a quadratic number pattern. And a standard form of a quadratic number pattern is given as Tn is equals to an squared plus bn plus c. So which is a quadratic number pattern formula, which you probably know the standard form in your parabola. So we're going to substitute our a value, our b value, and our c value to find our equation, right? So let me just remove this so that you can write our equation properly. So our equation is going to be, so Tn is equals to our a value we found to be 4, so it's going to be 4n squared. Our b we found to be minus 4, it's going to be minus 4n. Our c is 1, so it's plus 1. But remember that we need to write it in this format. So for you to write it in this format, you need to factorize. So we're going to factorize this, and you're going to have 2n as factors of 4n squared, and then the factors of 1 is just 1. Then you're going to put a negative there. So you can see that it's 2n minus 1 both. So you can simply say 2n minus 1 and put a squared outside. So that is the solution of Tn, which is basically the same as this one here. So that is how we solve 2.1.2. 2.1.3, we are asked to find the term of the sequence which is equals to 10,201, which is 10,201. So to find that term, we know the standard term, or should I say the formula of our quadratic pattern, 2n minus 1 all squared. That is the formula that we have, but we want to find n. We don't know n, since we are given that Tn is equal to 10,201, 10,201. So you're going to write 10,000 here, 10,201, 10,201 equals to 2n minus 1 all squared. It's like that. So we need to remove the square. So you're going to put a square root, right? So you're going to put the square root there, square root there. Then the solution from the square root, you're going to get 101 equals to 2n minus 1. Then you transpose the 1 to the other side, you're going to get 2n is equals to 101 plus 1, which is 2n is equals to 102. Divide by 2 both sides, you're going to get n being equals to 51. So that is going to be your solution of n. So now we're going to do 2.2, right? In this question, we are told that the first 24 terms of the arithmetic series are these ones. So we are given 24 terms, even though they didn't write the entire 24 terms, but you know that the first 24 terms will give us 35 all the way up to 196. So n is equal to 24, we know, for this sequence here. Which this sequence, if you check clearly, the difference is 7 for this sequence. So we know that d is equal to 7. The difference, common difference, is 7. You can minus, you can say 42 minus 35, you'll get 7. You can say 49 minus 42, you get 7. So the difference is 7. So now they say that you must calculate the sum of all natural numbers. So these are key. All natural numbers from 35 to 196 that are not divisible by 7. So when a question says this, it says that we want numbers that are not divisible. If something is not divisible by 7, which means you can't divide it with 7. So if I say 20 divided by 7, I cannot divide it by 7. Yes, it is going to be divided, but it will give me decimals. It will give me decimals. And you don't want that. You want a perfect number. So they're not divisible. So we want the sum of all natural numbers from 35 to 196. Remember that from 35 to 196, we have 24 terms that are not divisible by 7. So we want a sum which will give us natural numbers not divisible by 7. So the first thing you need to do here is to first find the sum of numbers that are divisible by 7. So you're going to look at your 35 plus 42 plus 49. So I'm writing this sequence here, plus 196. So you can see that the first 3 terms here are divisible by 7. So you can simply find the sum of this sequence. So sum, and since we're having a constant difference of 7, meaning our d is 7. So it's going to be, we're going to use this formula, n over 2 is equals to a plus l. L means last term. This means first term. And the n is number of terms. N means number of terms. Cool. So this is what you're going to do. So what is our n? We know that we're having 24 terms. We were told. And our a value is 35. A is the first term. This is 35. And our L, which is our last term, is equals to 196. So we were given the last term. So this sequence is finite, it has an end. So we have a last term of 196. So we're just going to substitute in this equation here. So S of 24 is equals to 24 over 2 into the first term, which is 35, plus 196. So the sum of this, you're going to get 2772. Right? So that is the solution for numbers that are divisible by 7. So the sum of 24 is equals to 2772. So this is for numbers divisible by 7. Remember that. These are for numbers divisible by 7. Cool. But we don't want a sum of numbers divisible by 7. We want numbers that are not divisible. We want a sum of numbers not divisible by 7. So there are numbers in between 35 to 196 that are not divisible by. For an example, the sequence, it says 35. What's the next number from 35? It's 36. So it's not divisible by 7. We want those numbers. We want a sum of those numbers. 36, 37, 38, 39, 40, up until 41. All these numbers are not divisible by 7. We want a sum of all these numbers, including the ones that are between here and between here. So we want those numbers. We want a sum of those numbers. Someone can just write these numbers. If you have time, you can just write all these numbers and add them together. That will be your answer. You will be allowed to get your 5 marks. If you have all the time, you can just do that. Just add all the numbers in between. That would be your sum. But just because we want to use our knowledge of sequence and series. So what you're going to do here, you're going to find the sum of natural numbers. So we know that, but for us to find the sum, we're going to still use the same equation, n over 2 into a plus l, right? But the difference here is the number of terms. How do you find the number of terms of all the natural numbers that are between 35 and 196? So what you're going to do is you're going to say 196 minus 34. Why am I minusing 34? 35 is divisible by 7, right? And 35 is within the range of numbers, because we want numbers that are between 35 and 196. So 35 is inclusive in that count. So I have to include it. Hence I'm using 34, which is less than 35. I want to include 35 as my terms because it's also a natural number. You can also consider it as a natural number. So when you subtract these two, you're going to get 162. So this is a total number of terms of natural numbers, all the natural numbers in the sequence, all of them, including the ones that are divisible by 7. So we are just including everything. So you're going to find the sum for that. So you're going to say the sum of 162 natural numbers, 162 over 2 into, what is the first term? The first term is 35. That's why I said inclusive, I subtracted 34. The first term is 35, even for natural numbers. Plus the last term, it's 196, so that didn't change. So if I write it properly, it's 162 over 2 into 35 plus 196. Then your solution for this one, you're going to get 18,711. Please confirm with the calculator, but this is the answer. So now you have, let me write this proper now. Now you have a sum of 24 terms, which is equals to 2772. I said it's this one here for numbers that are numbers. So this is N0, it's numbers that are divisible by 7, right? And then S of 162 is equals to 18711. It's a combination. Let me write it. It's a combination of numbers that are divisible by 7 and those not divisible by 7. So there's a combination here. Combination in this one, combination of those that are divisible by 7 and those that are not divisible by 7. But what do we want? We want numbers that are not divisible by 7. So we have to subtract from this larger sum because it consists of both those that are divisible by 7 and those that are not. So sum of numbers that are not divisible by 7 is equal to the sum of numbers that have a combination of both divisible and not divisible minus the sum of 24 which are divisible by 7. So meaning we're going to say 18,711 minus 2772. Then you're going to get an answer of 15,939. So this is the answer for numbers that are not divisible by 7. Question 3.1, we are told to consider the following geometric series. This is the geometric series given, and the first question says that for which values of x will the series converge? So whenever they ask you this, for which values of x or for which values of r, whatever, will the series converge, you know convergence is determined by this. R must lie between -1 and 1. So this determines convergence of a series, a geometric series rather. So for us to prove this convergence, we must find R in this geometric series. So to find R, we know it's going to be R equals to term number 2 divided by term number 1 is equals to term number 3 divided by term number 2. So this is term number 1, this is term number 2, this is term number 3, right? So R is equals to, our term number 2 is 5 into 3x plus 1 all squared. Our term number 1 is 5 into 3x plus 1 equals to, so the terms must be, the ratios must be equal for us to confirm that that is actually the ratio we're looking for. So here it's to the power 3 over 5 into 3x plus 1 to the power 2. So if you can see here, this is similar to this, so they divide out, and these are similar only because this one is squared and this one is 1. So you'll remain with 3x plus 1. So this is going to be your R in both sides. So it's going to be 3x plus 1. So that is your ratio. So you're going to put your ratio inside this convergence here. So you're going to say my convergence must lie between -1 and 1. But what is my R? It's 3x plus 1. Lie between -1 and 1. -1 and 1. So for us to solve here, you must transpose this one both sides. So you transpose it that side, you also transpose it that side. So we're going to have -1 because they change the sign from positive to negative, less than 3x, less than, so it's going to be the 1 which is this one here, and then -1. So you're going to have 3x less than, so this 1 minus 1 is going to give you 0, less than this -1 minus 1 is going to be -2. Divide by 3 both sides. You're going to have x lies between 0 because 0 divided by 3 is 0 and -2 over 3. So this is your convergence of series. This is your solution. X must lie between -2 over 3 and 0. So now 3.1.2, we want to calculate the sum to infinity of the series if x is equals to minus 1 over 6. So we want to find the sum to infinity. We know the sum to infinity equation. It's a over 1 minus r, right? But we know our r. Our r that we found in 3.1.1 is 3x plus 1. So basically what's inside here, it's common ratio. We calculated it, didn't assume from the given series. So our r is equal to 3x plus 1, and we need to find our a. So our a is the first term of the series. So a in this case, it's this one here, which is 5 into 3x plus 1. So let's substitute this in our sum to infinity, because we are asked to find the sum to infinity. So when I say sum to infinity is equals to our a, which is 5 into 3x plus 1, divided by 1 minus our r, which is 3x plus 1. So this is 3. Cool. So now, but you need to remember that we were given that x is equals to minus 1 over 6. So meaning where we see x, we put minus 1 over 6. So, excuse me, so it's going to be 5 into 3 into minus 1 over 6 plus 1 close bracket over 1 minus into 3 into minus 1 over 6 plus 1 close bracket. So the answer that you're going to get here is going to be 5. So that is your sum to infinity. So now we are going to do 3.2, which we are asked to determine the smallest value of k such that the sum is greater than 30. So if you check, it's greater than 30. So the sum, which is this one here, is greater than 30. So we need to find that value of k. For us to find that value of k, we need to find our sequence first, our series, right? So to find our series, we are given the sum p is equals to 1, 2 to the power p minus 4. So let's first find our series. So when p is equals to 1, because this is the starting point of our series, we're going to substitute 1. This 1 minus 4 is equals to 2 to the power minus 3. And then when p is equals to 2, it's 2 to the power of 2 minus 4, which is 2 to the power minus 2. When p is equals to 3, it's 2 to the power 3 minus 4, which is equals to 2 to the power minus 1. So now we have our series, which is 2 to the power minus 3 plus 2 to the power minus 2 plus 2 to the power minus 1. Someone wants to write it in fraction form. It's going to be 1 over 2 to the power 3 plus 1 over 2 to the power 2 plus 1 over 2. And someone can want to simplify it further. You 1 over 8 plus 1 over 4 plus 1 over 2. So this is your series, right? And we want to find the value of k. So for us to do that, let me eliminate the side used. So now we have our series. We want to find the value of k. So for us to find the value of k, we have to find the sum. We have to find the sum of k, right? We're already given that the sum is equals to 30. So the sum of k, because k stands for the number of terms, I assume it's at the top of the sum. I know that doesn't mean it's the number of terms in general sense. That k at the top doesn't mean the number of terms. So we're just gonna say s of k is equals to our a into 1 minus r to the power of k. Instead of writing n, divide by 1 minus r. Remember that the standard one is Sn is equals to a into 1 minus r to the power n. Let me remove this. Divide by 1 minus r. So this is the standard equation of a geometric series. So we're going to use this one. So where instead of writing n here, we're just going to write k. Cool. So the reason why we consider this k as n is because we're starting at p is equals to 1. So there won't be much effect because the number of terms, we find it by saying top minus bottom plus 1, of which the top is k, the bottom is 1 plus 1. So this cancel out, so n is equals to k. So that's how you can prove it, that actually k is equals to n. In this case, not all the time. So we're having our sequence here, which is this one here. We need to substitute. So our a value, which is this one here, it's actually equals to 1 over 8. Remember that this is our sequence, or our series rather. So our first term is 1 over 8, and this is a geometric sequence or geometric series. How do you prove that? You need to find the difference in ratios. So you're gonna divide to find the ratios of these. So you're gonna say r is equal to t2 over t1 equals to t3 over t2. If the ratios are the same, of which they are the same, I found 2 as my ratio. Therefore, this is a geometric series. So our r is equal to 2. So now we know our r. We don't know our k. And we know that s of k is equal to 30. It's not necessarily equal to 30. The sum must be greater than 30. Cool. So meaning here, you're just going to write 1 over 8 into 1 minus, our r is 2 to the power of k, divided by 1 minus 2. It must be greater than 30. So that's what the question says. So we're going to simplify this out to find the value of k. So remember that is the whole point, to find the value of k, such that it gives you a sum greater than 30. So what you're going to do is this. You're going to say, so you're going to solve this bottom, 1 minus 2, which is minus 1. So that minus 1 will multiply, cross multiply. You're going to multiply this 30. So we're going to have 1 over 8 into 1 minus 2 to the power of k. It's greater than minus 30. Then you multiply by 8 both sides. And then 1 minus 2 to the power of k greater than 30 times 8. Transpose the 1 to the other side. You have minus 2 to the power of k greater than 30 times 8 minus 1, right? Then your minus 2 to the power of k is greater than, if you do that problem, you're going to get minus 241, right? So it's minus 241. So here, what you do, you're going to remove the negative, divide by negative 1, divide by negative 1, both sides. You have 2 to the power of k. Because you're dividing by negative, the sign will change. From greater than, it's going to be less than 241. Right? So now you're having your 2 to the power of k is less than 241. So you're going to use your logs. Right? So this is your base. So remember that log works like this. Log, our base is at the bottom, and then this is our variable, equals to our exponent. So this is exponent, this is base, and this is just a variable. So we're gonna say we're gonna equate to the exponent. So our exponent is k less than our log of base, which is 2, and then our variable, or our value rather, it's equals to 241, just like that. So you're going to punch your calculator, so you're going to get k less than 7.9. So this would be the answer that you're going to get. So how you conclude is this, because you're not done. So you got k equals, you got k is less than 7.9. That's what you got as your answer, right? So what you need to do is you need to go back to the question. What does the question want? It wants solutions of k such that the sum will give you greater than 8. So for you to conclude from here, you can test. You can test in your sum formula, test for k it's greater than 7.9, for example, you can say k is equals to 7 and see if it's going to give you a sum that is greater than 30. So what do I mean? You have your sum formula, which is equals to a into 1 minus r to the power k over 1 minus r, and we said this is 1 over 8 into 1 minus 2 to the power of k over 1 minus 2. So you can test it in this formula here. Put your value of k here. Of k is equals to maybe 7, and see if it's going to give you a value that is greater than 30 here, which is what's required basically. So if it doesn't, which means your k value must be greater than that one. Like you can test 7.9, sorry, and see if it's going to give you a value that is greater than 30. If it doesn't, which means you're looking for a greater value than 7.9, which is the case. So if you say k is equals to 8, it will definitely give you a value or a sum that is greater than 30. So this would be your final solution. Okay, right. So in this question here, question 4, we are given this expression here. If you can see, it is actually a hyperbola. And the first question says that we must find the coordinate of the y-intercept of f. So we're having f of x being equal to 2 over x plus 1 minus 3. The y-intercept when x is equal to 0. So f of x is equal to 2 divided by 0 plus 1 minus 3, which is equals to 2 divided by 1 is 2 minus 3 is equals to minus 1. So this is your value of y. So in coordinate form, you're going to write 0 and minus 1. And then here in 4.1.2, we are asked to calculate the coordinates of the x-intercept of f. So the x-intercept when y is equal to 0, so in your equation of f of x is equal to 2 over x plus 1 minus 3. So where does f of x equals 0 is equal to 2 over x plus 1 minus 3. Take the minus 3 to the other side. You have 3 is equal to 2 over x plus 1. Then you cross multiply. So you're going to have 3 into x plus 1 is equal to 2. Divide by 3 both sides, or you can multiply inside, it's up to you. So I'm just going to divide. You have x plus 1 is equal to 2 over 3. Then you transpose the 1 to the other side. You have x equals to 2 over 3 minus 1. So therefore our x is going to be equals to minus 1 over 3. So your coordinate form is minus 1 over 3 and 0. And then we are asked to sketch. So in 4.1.3, we are asked to sketch the graph and show clearly all the asymptotes and x-intercepts. So I'm just going to write the graph just here at the bottom. So we're having our intercepts. So we have our x-intercepts, which is minus 1 over 3. We have our y-intercept, which is 0 and minus 1. So it's important. And our asymptotes. So we have our equation is this one here, our asymptotes. Our vertical asymptote is equals to minus 1. Our horizontal asymptote is equals to minus 3. So when you draw your graph, your minus 1 because it's vertical, so it's vertical asymptote, which is x equals to minus 1, and your horizontal asymptote, which is so let me do this. So you're having your Cartesian plane. This is your y, this is your x, and this is your vertical asymptote. Your horizontal asymptote is given as y is equals to minus 3. And you've already found your x-intercept. Your x-intercept is this one, minus 1 over 3 and 0. So minus 1 over 3, it's minus 0.333. So it's just here before negative 1. You're going to indicate that it's actually a minus 1 over 3 and 0. And then another coordinate, it's 0 and minus 1, which is here, which is 0 and minus 1. So you're just going to join your points together, and this would be your graph, and another one here. So how do you know that this is in this plane? How do you know that we should draw it here and not the other sides, like here and here? So we see by the value of a. So if you see our equation, which is this one here, let me write it properly. So it's f of x is equal to 2 over x plus 1 minus 3. So in this equation here, our a value, which is this 2 here, our a is equal to 2. So our a is greater than 0. So when a is greater than 0, so let me indicate here, our hyperbola is going to be in the first and third quadrant. So when a is greater than 0, meaning it's positive, our hyperbola is going to be in the first and third quadrant. So these quadrants are actually your asymptotes. It's not just your Cartesian plane. You look at the asymptotes. Cool. So when a is less than 0, in between your asymptotes, your hyperbola will be in the second and fourth quadrant. So that's how we drew our sketch here. So in 4.1.4, we are told that one of the axes has an axis of symmetry, or one of the axes of symmetry rather of f is decreasing. So we must determine the equation of the axis of symmetry that is decreasing. So we have two axes of symmetry. So if you draw your asymptotes, let's say these are the asymptotes for a graph of a hyperbola that is greater than 0, meaning this graph will lie in the first quadrant of the asymptotes and the third quadrant of the asymptotes. So your axes of symmetry, they're always passing through your asymptotes, always. So this is the positive axis of symmetry. Positive, meaning the gradient is equals to 1. Sorry. So this is the negative axis of symmetry. It's decreasing. So meaning the gradient here, it's equals to minus 1. So this is the gradient of the axis of symmetry, this one here, because it's decreasing. And then another axis of symmetry passes through here, which the gradient for this one is increasing, so it's plus 1. Right? So if you were to write the equations of this specific parabola, you're going to say y is equals to mx plus c, right? Which it would depend where your c is, but what you need to note is your gradient for the positive one is going to be x plus c. So you're gonna use your asymptotes to find c. So you're gonna use your asymptotes as a point, right? So let's say, for example, your asymptote is 0 and 0. So you're gonna substitute 0 here and 0 here, so which means your value of c is 0, right? So your asymptotes, you always use them for substituting as a point, because these are your asymptotes. They're passing through these two lines here. Cool. So now let me solve this problem here, which says that we must now find the equation of the negative axis of symmetry, -1. So the negative one, or the decreasing one, because something that's decreasing, it's just showing a negative sign. So it's m equals to -1. We know the gradient. So the equation is y is equals to mx plus c, but you know it's y is equals to -x plus c. So the point that we're going to use to substitute to find c is the point of the asymptotes, as I said, asymptotes. So you're going to substitute the asymptotes. We know that in our equation we have the vertical asymptotes, as you can see there. I'm just going to go back. This is the vertical asymptote, which is equals to x equals to -1, so this is -1. Horizontal asymptote, it's equals to -3, so y is equals to -3, so you write it here, it's -3. So you're going to substitute it in this equation. So this is y, this is x. So where there's y, you put -3 equals to negative, where there's x, you put -1 plus c. So this is going to be 1 and this is going to be -3. Transpose the 1 the other side, it's going to be -3 minus 1 is equals to c. Therefore, c is equals to -4. So the equation of the negative decreasing axis of symmetry, it's y is equals to the minus x minus 4. So this is the equation. So now in this problem here in 4.2, we are given a function of this equation, which is sketched here below, and we are given that point C is the x-intercept of t, and A is just the point at t. So this is A, and this is your C. And then we are required to find the coordinates of C. So how do we find the coordinates of C? We have t of x is equals to log of base A x. So we want to find 4.2.1, right? So what is your t? This is c, right? So if you were to assume or write the coordinates of c, we don't know the value of x, but we know the value of y, which is 0. So meaning here at t of x, we're going to write 0 is equals to log the base. We don't know the base, so just going to write a and then x. Then to write properly, you're going to say x is equals to a to the power of 0. Anything to the power of 0 is 1. So meaning our x value is 1. So x is equals to 1. So therefore your c in this case is going to be 1 and 0. That's why it's 1 mark. So it's going to be 1 and 0. So this is your answer for 4.2.1. Now 4.2.2, we are asked to write down the range of the graph of t. So the range, looking at this, so when you talk of range, because there's a domain and there's a range. The range, we focus on the y values of the graph. We interpret how the y values are operating, are moving. So if you look at this graph here that is given, the y values come from a certain point up there. We don't know from which point, and they go to, so it's how you interpret it. Because this is an exponential graph, you can interpret it from the bottom to the top. Why? Because the bottom has negative y values. Remember that here it's negative y, here it's positive y. So this graph comes from a negative infinity of y, and then it goes to a positive infinity of y. It's going up and it's going down to values we don't know. So to find the range of y, we're going to say y is the element of negative infinity to positive infinity. So this is your range. And then now we are asked to find the value of a. So we know our t of x, the given equation, it's log base a x, right? And we want to find this a value here. So to find this a value, you need to substitute a value here and a value here at x. So what are you going to use? You're going to use a point. So in this case, you're going to use the point of a, which is 5 and minus 1. We're given this point here, which is 5 and minus 1. So we're going to substitute it in this equation to find our value of a. So which means where there's t of x, you put minus 1 is equals to log the base a x, you put 5. So to write it properly, you have minus 1 is equals to log base a 5. So a to the power minus 1 is equals to 5. right? And we want to find a is equals to not a to the power minus 1. So you can multiply by 1 over minus 1, 1 over minus 1, or you can simply just write it in this form. You have 1 minus to the power minus 1 is equals to 5, right? Write it as 1 over a is equals to 5. Cross multiply, you have 1 is equals to 5a. Divide by 5 both sides, you have a is equals to 1 over 5. So this is your a value. So now we are looking at 4.2.4. It says that the graph of h is equals to t of x is transformed by a reflection of t about the line y is equals to x. So the original graph is transformed. So we are required to write down the equation of h in the form y is equals to. So this is what's happening here. We go back to our graph. Let me erase everything here. So the given graph looks like this, right? And we are told that we want to find the equation of h, which is equal to t of x. But it's the reflection of this about the line y is equal to x. So the line is equal to y is equal to x is this one. This is the line of y is equal to x, where the y value is equal to the x value. Now we want to find an equation of h. So meaning it is going to be the inverse of t, because a graph that is reflected about this line of y is equals to x is an inverse, right? So we know that t of x is equals to log of base ax, of which we found, but a was equals to 1 over 5. We just calculated it. So meaning our t of x is equals to log base 1 over 5 x. So this is our equation of t of x, which if you write it properly, you're going to say y is equals to log base 1 over 5 x. But because we want to find the inverse of this, the inverse is the exponential equation. So what you do, you just write this in exponential form, right? So meaning the 1 over 5, which is this base here, to the power of y is equals to x. But remember, when you do the inverse, we swap. Where there's x, you put y. Where there's y, you put x. So meaning here, 1 over 5 to the power x is equals to y. So y is equals to 1 over 5 to the power x. So this is our equation of h, which is a reflection of t. Then now, so we are done with this, So now we want to do 4.2.5. Write down the domain of h. So we know the equation of h. h is equals to y is equals to 1 over 5 to the power x, right? The domain. So when you talk of the domain, we're talking of the x values. We want to interpret the x values. If you look at this graph here, the reflection of this graph will pass through here, basically. So this is the graph of h, right? So the x values come from that direction, the negative infinity and they go to a positive infinity. The x values, the domain. So to confirm the domain of h, we are simply going to say x is the element from negative infinity to positive infinity. So that's the domain of the function. Now let's go to 4.2.6. Write down the equation of the asymptote of h. So now we want to find the equation of the asymptote. You already have the equation of h, which is y is equals to 1 over 5 to the power x. Normally the asymptotes of an exponential, it's written here, it's plus a certain value, of which this equation doesn't have that. It's just this expression here, meaning your y is equal to 0. Your horizontal asymptote is 0. So that is the solution for this problem here. Okay, now we're on question 5. We are given this equation here of a parabola, and 5.1 we are asked to find the gradient of the tangent of the parabola at this point. Oh, the gradient of the tangent to this point is actually 3, so we are asked to find the value of a and b. So we are given the gradient, so meaning if you are given the gradient, you know the gradient is f prime x, so it's equals to 3. We are also given a point which is minus 1 and 7 over 2, and we're asked to find the value of a and b. So the first thing you can do here is derive the given equation. So we have f of x being equals to minus ax squared plus bx plus 6. So derive this, you get minus 2ax plus b. But we know that this f prime of x is 3, so the gradient is 3, so it's 3 is equals to minus 2ax plus b. And according to this point, we know x is equals to minus 1, so you're going to substitute minus 1 here, so it's going to be 3 equals to minus 2 into, or minus 2a into minus 1 plus b. So you're going to have 3 is equals to 2a plus b. So to write this proper, b is equals to 3 minus 2a. So this would be your equation 1. Then equation 2, we're going to use the original equation, equals to minus ax squared plus bx plus 6. Then we use the point that is given of minus 1 and 7 over 2. So we substitute 7 over 2 here, and where we see x we put minus 1. So 7 over 2 is equals to minus a into minus 1 squared plus b into minus 1 plus 6. Cool. So here you're going to 7 over 2 is equals to, so minus 1 squared is just going to give you minus a minus b plus 6. Then you transpose the 6 to the other side, you will have minus 5 over 2 is equals to minus a minus b. Then you divide by negative all sides, then you're gonna have 5 over 2 is equals to a plus b. Then you write it in terms of b. B is equals to 5 over 2 minus a. This is your equation 2. So to find what is required, a and b, so let's equate the equation. So you have equation 1 with equation 2. Let me erase this. So now we have two equations we're going to solve. So equation 1 is equals to equation 2. So what is equation 1? B is equals to 3 minus 2a is equals to. Equation 2 is 5 over 2 minus a. So you can transpose this 2a to the other side and transpose this 5 over 2 to the other side. So you have 3 minus 5 over 2 is equals to 2a minus a. What you'll get is 3 minus 5 over 2, you're going to get 1 over 2 equals to 2a minus 1, you're going to get a. So a is equals to 1 over 2. Then for b, you say b is equals to 5 over 2 minus a. You're going to use this equation, or you can use this one. Then 5 over 2 minus our a, which is 1 over 2. And therefore, our b is going to be equals to 2 if you use your calculator. So we've proven that b is equals to 2, a is equals to 1 over 2. So 5.2, we are asked to find the x-intercept of f. So remember that f of x is equals to minus ax squared plus bx minus 6. And we found that a is equals to 1 over 2, b is equals to 2. So we're going to substitute that. We're going to have minus 1 over 2x squared plus 2x minus 6. So this is your equation. This is your equation. So we are asked to find the intercept. So the x-intercept when y is equals to 0. So meaning it's going to be 0 is equals to minus 1 over 2x squared plus 2x minus 6. So you're going to divide by negative half throughout. Then you'll have 0 is equals to x squared minus 4x minus 12. Then you factorize this. It's going to be x, and then you're going to use 6 and 2. So your 6 would be negative and this would be positive. So x is equals to minus 2 or x is equals to 6. So these are your x-intercepts. So now we want 5.3. Calculate the coordinates of the turning point of f. So now we know f being equals to minus half x squared plus 2x plus 6. So to find the turning points, we're going to say x is equals to minus b over 2a, of which minus our b is equals to 2 over 2, our a is equals to half. So our x value of the turning point is going to be equals to 2. Then we substitute the x value in the original equation. So minus half into 2 squared plus 2 into 2 plus 6. So we're gonna get 8. So your turning point is 2 and 8. So now 5.4, we are asked to sketch the graph of f and show clearly the intercepts and the turning point. So if I were to draw this graph, let me find proper space to draw it. To draw the function, this is Cartesian plane. And we have our intercepts. So our x-intercepts we calculated in previous questions. We found x being minus 2, y being 0, and we found x being 6 and 0. So those are the x-intercept and the y-intercepts of the function. When x is 0, we found x being 0 and y being 6, and the turning point we found 2 and 8. Cool. So to start with the turning point, it's 2x, so we're gonna write 2, assume this is 2, and then our 8, assume it's at the top, so this is the point of the turning point, which is 2 and 8. And then we have the y-intercept, which is here at coordinates 0 and 6. And then we have the x-intercept, which is here at coordinate minus 2 and 0. Another x-intercept here, which is at 6 and 0. Then we join the points to find our parabola. So this would be your parabola. Make sure you label every intercept and your turning point. Now we're going to do 5.5. Use the graph to determine the values of x such that f of x is greater than 6. So f of x is greater than 6. So what are the values of x when f of x is greater than 6? So that's what this means. What are the values of x when f of x is greater than 6? So we're going to go to the graph. Go to the graph. So when the y value is greater than 6, so this is where that happens. It's here. Sorry for that. So it's here. Just here. Any direction that faces. So it's everything that is in here. It's greater than 6. So f of x is greater than 6 because where f of x is equal to 6, it's at this point. So anything greater, it's anything that I've shaded here. It's greater than 6 from the graph. Cool. So so we are asked to find the values of x when that happens. So you can simply look at some of the critical points between this point and this point here. F of x is greater than 6 because the y value from here, it's just at the top. It's here. It moves to the top. It's greater than 6. So you can simply say when x lies between, because at this point here x is 0 and on the turning point it's 2. So you can simply use this and say this is where f of x is greater than 6. 5.6 sketch the graph of g of x is equals to minus x minus 1. So you're asked to sketch the straight line on the same set of x's and indicate all intercepts. So what you're going to do is you're going to first find the intercept of this graph here. So the equation we are given g of x is equals to minus x minus 1. So we're gonna erase this. So g of x is equals to minus x minus 1. So to draw this, you have to find intercept. So the x-intercept when y is equals to 0, what do you say? So 0 is equals to minus x minus 1. Transpose the one that side, you have minus x equals to 1, which is therefore equals to minus 1. So the point is minus 1 and 0. And then the y-intercept when x is equals to 0, you have y is equals to minus 0 minus 1. So it's equals to minus 1. So the point is 0 minus 1. So these are the points. So let's start with this 0 and minus 1, which we can assume it's here. 0 and minus 1. And minus 1 and 0, you can assume it's here. Minus 1 and 0. So we join the straight line. Looks like this. So now we are asked to find, so it's 5.7. Write down the x or the values of x such that when you multiply the graph of f and the graph of g, they give you a solution that is less than or equal to 0. So we want the values of x when that happens. So I'm going to interpret from the graph that we drew. So this is what's happening. When f of x multiplied by g of x, and we get a solution that is less than or equal to 0. So when the y value of f multiplies the y value of g, it must give you a solution that is negative or equals to 0. That's what this means. So you're going to look where your graph multiplies each other, or where the signs. So if, let's say, for example, you look at this point here. This is your graph of f, right? And the sign at this point, it's for the y values, sorry. The sign at this point for this graph, oh, let me draw it again. Okay, so at this point of the graph, the signs are negative. The y values are negative. Why? Because this is a negative part of y. So the y's are negative at this point. So when you multiply a negative with a negative, you get a positive, right? Negative multiplied by positive, you get a negative. A positive multiplied by a positive, you get a positive. So I'm more interested in negative solution, or equals to 0. So here it's negative. If you want to multiply this negative y value with another y value of this part here, if you were to multiply this part, this y value of g of x, of which at this point the y values are positive here. Y values are positive. So if you multiply this positive with this negative, you should get a negative solution, which is what you are looking for. That's why they gave us this. So so where does that happen? It happens at this point when x is minus 2. That's why I'm including everything that is facing that direction. I know it's a bit messy now. So you can simply say when x is less than or equals to 2, this solution of x, that's where your y multiplies with your y. The y of f and the y of g multiply together and get you a solution that is less than or equals to 0. So this is the first solution of x that is needed there. And then where does that happen again? So we're going to have a look. If you take a look at the graph, let me see here at this point here, the y, it's negative. If you go to the graph of f that correlates with this straight line, the y's are positive at this point. The y's are positive, just correlating with this portion here. So you can simply say this. Another solution can be when x, because x at this point it's 0, when x is greater than 0, greater or equals to 0, or x must be less than this point here, because after this point this graph becomes negative, and we don't want to multiply negative with a negative. So or x must be less than or equals to 6. So this is another solution of x where this happens, right? So you can conclude by saying when x is less than or equals to 2, or when x lies between 0 and 6 inclusive. You can write it like this, or you can write it exactly like what I did here. Okay, so now in question 6, Janet invests a lump sum of 5,000 Rand into a savings account for a period of 2 years. The investment earns interest rate of 10% compounded quarterly, 6.1.1. What is the quarterly interest rate for Janet's investment? So we are told that the interest is compounded quarterly. So the interest rate for Janet is going to be equals to 10% divided by 4, which is 2.5%. 6.1 1.2. Calculate the amount in Janet's savings account at the end of 2 years. So I want to know the amount of Janet in 2 years time in her account. So what we can do is gonna write it here. So we know we are using a compound formula. So we know that we're using a compound formula. A is equals to P into 1 plus I to the power n. And P is the investment of Janet in her savings account, which is 5,000 Rand. And the interest rate, we just stated that it's 2.5%. Why? Because it's compounded quarterly. It's compounded quarterly, and n is equals to 2 years. So you're gonna say 5,000 into 1 plus 2.5% to the power of 2 years. So what you need to note is that we wrote 2 years at the top, so you need to multiply by the 4, which is for quarterly. So normally you would write A is equals to P into 1 plus I to the power n, which is 5,000 into 1 plus, so the percentage, it was 10%, so it's going to be 0.01 divided by the quarterly, which is 4 to the power 4 times 2 years. So that is the normal way of doing it. Then the answer that you're going to get is 6,092 Rand 0.01. So that's the answer for here and also for here. 6,092 Rand 0.01. So this is 992 Rand 0.01. So that is the amount of money in Janet's savings account. So now in 6.2, we are told that Sihle inherits 800,000 Rand. He invests his entire inheritance in a fund which earns an interest rate of 14% per annum compounded monthly. At the end of each month, Sihle withdraws 10,000 Rand from the fund. His first withdrawal is exactly 1 month after the initial investment. So 6.2.1, we are asked to calculate how many withdrawals will Sihle be able to make from his fund account. So from the information given, we know that Sihle, the person we are talking about, Sihle, has an inheritance of 800,000 Rand, and the interest of the savings that he does is 14%, and it's compounded monthly. And one other thing that we can take from the question is he makes withdrawals of 10,000 Rand. So now we want to know how many withdrawals will Sihle make. One thing we need to note is we're having a lump sum here. We're having a lump sum that we are depositing in the account. So when you have a lump sum and you receive your income in certain periods, it can be monthly, can be quarterly, but you are receiving income in a certain period of time, then the formula to use it is a present value annuity, which is PV is equals to x into 1 minus into 1 plus I to the power minus n divide by I. So PV, we know it's 800,000 and X is 10,000, so it's those withdrawals that Sihle makes. And interest rate, it's 14% compounded monthly. And when we say we want to know the number of withdrawals, we want to know N, which we normally say it's number of payments. So we are told that he makes withdrawal immediately after the payment. So the payment happens at T0 and then at T1. So at T0 he makes a payment of 800,000. So that's his investment in the account. And then immediately here he takes, or he receives rather, as income, makes withdrawal of 10,000 rand. So we want to know the period. So it's going to be, or not the period rather, but the number of withdrawals. So we're going to say PV is equals to X into 1 minus 1 plus I to the power minus N. So let me write it nicely. So it's minus N divided by I, which it's 800,000 and 10,000 here, into 1 minus 1 plus 14%, which is 0.14, divided by compounded monthly, which is 12 to the power minus N, all divided by 0.14. So but let me just remove this and write properly at the bottom. So it's going to divide by 0.14 over 12. So you're going to multiply, cross multiply, so it's going to be 800,000 multiplied by 0.14 over 12 is equal to 10,000 into 1 minus 1 plus 0.14 over 12 to the power minus N. So make sure that you punch the values towards the end, so you don't punch during calculation. So you divide by 10,000. Then we have 800,000 times 0.14 over 12 divide by 10,000 is equals to 1 minus 1 plus 0.14 over 12 to the power minus N. Then we transpose the 1 to the other side, so you have 800,000 times 0.14 over 12 divide by 10,000 minus 1, because it's going to change sign when it goes to the other side, equals to negative into 1 plus 0.14 over 12 to the power minus N. Then from here you will punch this value in your calculator. So in my calculator I'm getting minus 0.0666, let me just say 667 equals to minus into 1 plus 0.14 over 12 to the power minus N. And then we divide through the negative, then you remain with 0.06667 equals to 1 plus 0.14 over 12 to the power minus N. Then we're going to use logs. So if you remember your logs, it says that if you have an exponent equals to, so it's going to be, so the exponent is outside, and then you have your log, you have your base, and then you have your variable here. So meaning in our problem here, our exponent is going to be this one outside, so we will say Okay, so now we need to remember our logs. This is an exponent, this is the base, and this is just the number. So according to our logs, it's log, here the a is a base, and if I write x, it's going to be just the number. So that's how we write our log. So it's going to be equals to the exponent, right? So to write this properly, we're going to say our minus n, which is the exponent, it's equals to log. Our base, it's 1 plus 0.14 over 12 multiplied by our value, or you just write inside the log is 0.06667, and minus n, you should get an answer of minus 233.465. Divide by negative 1, divide by negative 1, n is equals to 233. Let's just leave it here. So these are the number of withdrawals that Sihle makes. So now we go to 6.2.2, which says that exactly 4 years after the initial investment, Sihle decides to withdraw all the remaining money on his account. So in 4 years time, he just wants to withdraw the entire amount of money in his account. So the first question says that what is the value of Sihle's deposit to the closest rand? So what we are told here is that Sihle wants to withdraw all money in 4 years time, right? So what was the inheritance? It was 800,000, right? At 14% compounded monthly. So he wants to withdraw all the money in 4 years time. So what we need to first do is calculate the amount of money in 4 years time. Want to know how much will the money be in 4 years time. So remember that this is money that he inserted in his account. So he inserted 800,000 at T0. Then he made withdrawals at T1, but for now we don't really not really interested in that. But we know that he made withdrawals. He made constant withdrawals of 10,000. That's what we know. So we want to know at T4, which is 4 years. So the T1, it is in 1 month time. So we want to know in 4 years, which is going to be T48. We want to know how much is money in the account in 4 years time as he withdraws and continues to withdraw his money. So to calculate the amount of money in his account in 4 years time, so it's A is equals to P into 1 plus I to the power N. We know P is the amount of withdrawals that he was making of 10,000 Rand, and I is equals to 14%, that is compounded monthly, and N is the period, which is 4 years. So we're going to say 10,000 into 1 plus the interest rate 0.14 divided by monthly, which is 12 times 4. So the amount of money that would be in the account is 1396005.535. So this is the amount of money that will be in his account, right? If let's say, for example, we assume that this 10,000 rand is being invested into the account, then we'll be having this amount of money into the account. But we want to know how much money will be in the account in 4 years, right? So this would be the total amount, and then we will use our future value annuity formula. So the reason why we're using this formula now is because we want to know the future value of money into the account as we are making these withdrawals of 10,000 rands, right? How much will there be in the account? So it's going to be 10,000 into 1 plus 0.14 divided by 12 to the power of 12 times 4, which is 4 years, minus 1 into, so divide by 0.14 divide by 12. So the future value is going to be 638,577.36. So this would be the future value. Now the remaining amount, so this is the money in the account. So you're gonna say the amount, or the total amount rather, that was withdrawn in 4 years minus the total amount invested. All right, so you're gonna have your 1,396,005.535 minus 638,577.36. Then you will remain with 757,428.1749. Right, so this would be the amount that would be in his account in 4 years time as he makes these withdrawals, constantly making these withdrawals. So now the B part of 6.2.2 says that Sihle deposits exactly 30% on the purchase price of the house, right? So what is the purchase price of the house to the nearest rand? So remember that we wanted to know how much money was remaining in his account for him to deposit for a house, right? And we did calculate that amount there, which we found to be, let me write it here, which we found to be 757,428.1749. right? So this was the amount that he was going to use to deposit for the house. So now in B we want to know, they say Sihle's deposit is exactly 30% of the purchase price of the house. So what is the purchase price of the house to the nearest rand? So this is just the deposit, right? And we know that we having 30%, so this is the purchase price of the house, which is 30%. So we want to know the amount or the purchase price of the house exactly. So we're going to say the 30% multiplied by X, which is the amount of the house. So we don't know the price of the house, but we know that 30% of the amount of the house. So this is the amount of the house. So we know that 30% of this amount of the house will give you this deposit value, So that is a deposit value, which is 30%. So it's going to be 757,428.1749. So we're going to divide by this 30%. Divide by this 30%. And then the amount of the house will be equals to the deposit of 757,428.1749 divided by 30%. Remember, you need to either punch 30% in your calculator as a percentage or as 0.3, right? Then the answer that you need to get is 2,524,760.583. So this is the amount of the house. Okay, so now we're doing question 7, and we are given this equation here of g of x is equals to 1 minus 4x squared, and we are asked to determine the derivative using first principles. So the first thing you need to do here, before you even determine the derivative using first principles, you need to determine the derivative so that you know which answer you're looking for. So the derivative of 1 is 0 minus we drop the 2, 4 multiplied by x to the power 2 minus 1, then you have minus 8x. So you know that the derivative you're looking for in first principle is minus 8x. So let's find the derivative of this problem here using first principles. So the first thing we're going to do is we write our g of x, which is equals to 1 minus 4x squared, and first principles is written as f prime of x limit when h approaches 0, f into x plus h minus f of x divided by h. Then the limit when h approaches 0, so instead of writing f x plus h, so you're going to substitute it in your g of x. It's going to be g x plus h, which is equals to 1 minus 4 into x plus h all squared. Then it's going to be 1 minus 4 into x plus h squared minus, so this, instead of writing f of x, going to be g of x. So it's your g of x is this one here, 1 minus 4x squared divided by h. So your limit when h approaches 0, so let's find this portion here, x plus h all squared. So x plus h all squared is equals to x plus h, x plus h. Then we multiply through using FOIL method. It's going to be x squared, this and that, then plus hx, this and that, plus hx plus h squared. So giving you x to the power 2 plus, so let me write it proper. So it's going to give us x squared plus 2hx plus h squared. So you're going to write that here. So it's going to be 1 minus 4 into, you write x squared plus 2hx plus h squared minus into 1 minus 4x squared divided by h. Then your limit as h approaches 0, so the 4 will multiply everything that is inside here. So it's going to be 1 minus 4x squared minus 8hx, which this multiplied by that, and then, so this is x, and then minus 4h squared. Then this minus will multiply the 1, it's going to be minus 1, minus multiply the minus 4x squared, it's plus 4x squared divided by h. So the limit when h approaches 0, so the 1 will go away with this one, the 4x squared go away with that one, so we'll remain with minus 8hx minus 4h squared divided by h, which is equals to the limit when h approaches 0. So we're going to factorize the h, this h here, we're going to factorize it so that we cancel out with this one. So we're going to say h outside minus 8x minus 4h divided by h, then the h cancels out, then we are left with the limit when h approaches 0 is equals to minus 8x minus 4h. So where there's h, we'll substitute this 0 here. So we're gonna have minus 8x minus 4 into 0, giving us minus 8x. So this would be our answer for f prime of x using first principles. So we are done with 7.1.1. Now we're looking at 7.1.2. So it says, hence calculate the gradient of the tangent of f at x is equal to 2. So we know that g of x was 1 minus 4x squared, right? And when they say the tangent of f, you basically, I'm assuming they're now making this g of x as f of x, since the derivative of f of x was minus 8x. So please don't be confused by that. Okay, let's say this g of x is f of x, it's 1 minus 4x squared, and we found the derivative using first principle as minus 8x. So to find the gradient of the tangent, which is this one here, we're going to substitute the x here. So we know that x is given as 2, so the gradient of x equals to 2 is equals to minus 8 into 2, which is equals to minus 16. So that is the gradient of the tangent. Then we go to 7.2. We determine the derivative of this problem here. So this problem here, we have f of x is equals to the cube root of x squared plus 1 over 4x to the power 4. So the first step you need to do here, you need to write it properly in a way that you'll be able to factorize. I mean, you'll be able to derive. So you're going to say x squared to the power 1 over 3 plus, you take everything at the bottom to the top, so it's going to be 1 minus, so the 4 remains, then you have multiplied by x to the power minus 4, and then equals to, so you have the 1 over 3 multiplying the 2, which is x to the power of 2 over 3 plus x to the power of minus 4 over 4. So that is the sum. Let's write it here. So we are having x squared over 2 plus x to the power minus 4 over 4. So this is our f of x, right? So to derive this, we will, okay, this is 3. We're going to drop the power here to the bottom and subtract with 1. Same thing here, we drop the power here and subtract with 1. So we're going to say 2 over 3 multiplied by x to the power of 2 over 3 minus 1 plus minus 4 multiplied by 1 over 4x to the power minus 4 minus 1. Then we'll have 2 over 3 x to the power of minus 1 over 3 minus 4 times 1 over 4 x to the power minus 5. And then we will have 2 over 3 x to the power of minus 1 over 3 minus x to the power of minus 5. Then we write it properly as 2 over 3 x to the power of 1 over 3 minus 1 over x to the power of 5. So you can leave it like this if you want. 7.3, we are given h of x being equals to ax squared, and we are told that x is greater than 0. So we are asked to determine the value of a if we are given h to the power of minus 1 into 8 is equals to h derivative of 4. So what you need to note is that this is the inverse of h. This is the derivative of h. So we need to do that. We need to find the inverse and find the derivative and substitute these values that we are given here. So that's what you're going to do here aside. We know that we have h of x being equals to ax squared, and we are given that h of the inverse of h, substituting 8, is equals to the derivative of h substituting 4. So let's find the inverse first. So the inverse of h. So what you're going to do is we have h of x is equals to ax squared. Let's write it as y is equals to ax squared. So the inverse, you swap, x becomes y and y becomes x. So you're going to say x equals to ay squared, divide with the a. We have y squared is equals to x over a. Put the square root. Your y is equals to the root of a, and your y is equals to the root of x over a. So remember that h of the inverse, we're substituting 8 where there's x. So meaning therefore your y is equals to the root of 8 over a. So let's say this is equation 1, because remember we want to find the value of a. So now we're going to focus on the derivative of h. So to find the derivative, we have h of x being equals to ax squared. Derivative of h is equals to 2ax. And what's inside the derivative? We are given 4, so it's going to be 4, so it's going to be 2a into 4. And then the derivative 4 is equals to 8a. So this is equation number 2. And we are told that h of 8 is equals to the derivative of 4. So you're just going to write the equation as they are. So this one here, you're going to write it as the root of 8 over a being equals to what we got here as 8a. Remember, we're trying to find a, so we're going to square both sides to remove the square roots, and then we'll remain it 8 over a is equals to 8 squared. So this squared will multiply any power that it finds here. it's going to be 8 squared a squared. Having 8 over a is equals to 64 a squared. And then to complete this on a new page, we have 8 over a equals to 64 a squared. Then you cross multiply, you're going to have 8 is equals to 64 a cubed. Then you divide by 64 both sides. You have a cubed is equals to 8 over 64. Then you multiply by 1 over 3, multiply by 1 over 3. So your a value you're going to find to be 1 over 2. So this is the answer of A. In this question here, we are given a graph of g of x and a graph of h of x. So in 8.1, we are asked to determine whether the graph of h intersects the graph of g at its point of inflection. Show all necessary calculations. So the first thing we're going to do here, we're going to write the equations of our graphs. So the graph of g of x is equals to x cubed minus 3x squared, and the graph of h of x is equals to minus 2 over 3x minus 4 over 3. So we are asked to determine whether the graph of h of x intersects with the graph of g of x at its point of inflection. At its point of inflection. So for us to solve this problem, we must first find the points of inflection of the graph of g. So we first find the first derivative, which is 3x squared minus 6x, and the second derivative, which is equals to 6x minus 6, right? And for us to identify whether or not it intersects with the graph of g at the point of inflection, we must first find the point of inflection. So we equate the second derivative to 0. So 0 is equal to 6x minus 6, and then 6x is equals to 6, divide by 6 both sides, x is equals to 1. So this is the point of inflection. So we want to know whether the graph of g of x intersects the graph of h of x at this point of inflection. So now we're going to substitute the graph of we're going to substitute x at g of x. So it's g into x equals to 1 being equals to 1 cubed minus 3 into 1 squared. So we are substituting the x value in the original equation of g of x, right? So which is what we did here. So the answer that you should get, it's minus 2. So this is the solution of y when you substitute x being equals to 1. So we have to substitute the same value of x being equals to 1 on h of x to see if it's going to give us the same y value. So h when x is equals to 1 equals to minus 2 over 3 into 1 minus 4 over 3. So if you punch your calculator, you should get minus 2. So the fact that we are getting same values of y when we substitute the same value of x, it means now that the graph of h of x intersects with the graph of g of x at its point of inflection. So now 8.2, we are asked to determine the stationary points of y, which is equals to g prime of x, and classify these stationary points as either maximum or minimum. So what you're going to do is we want to identify the stationary point first. So we know that g of x is equals to x cubed minus 3x squared. So to find the stationary point, we have to find the first derivative of this cubic function, which is 3x squared minus 6x. And we equate to 0, so we have 3x squared minus 6x equals to 0. Then we factorize 3x, and we are left with x minus 2. So let me write this 2 properly. So we're going to be left with x minus 2 equals to 0, and 3x being equals to 0, or x being equals to 2. So x equals to 0 or x equals to 2. So these are the stationary points. So we have to identify whether or not they are at a point of minimum or maximum, right? For the graph of y is equals to g prime of x, which is a parabola. So what we're going to do is we're going to substitute these values here, x equals to 0 and x equals to 2 in the graph of g prime of x to find the y values, right? To find the y values. So when g prime of x, when x is equals to 0, what is our y value? So we're going to substitute them in this equation here. So it's going to be 3 into 0 squared minus 6 into 0. So basically our y is 0. And then when g prime of x, when x is equals to 2, what is our y? So it's going to be 3, it's going to be 2 here squared, and then there's 3 outside, minus 6 into 2. So you're going to get 3 times 4 minus 12, which 3 times 4 is 12, so it's going to be 12 minus 12 being equal to 0. So this confirms now that when x is equals to 0, y is equals to 0. When x is equals to 2, y is equals to 0. So to draw our function, because we want to know whether or not this function is a minimum or maximum, right? So we're going to draw it. So when drawing our function, we need to identify our intercepts, right? Because if you derive a cubic function, you're going to get a parabola, and the derivative of a cubic function gives you turning points of a cubic function, but the derivative of a cubic function gives you the intercepts of a parabola. So these are the intercepts of a parabola, x equals to 0 and x is equals to 2. And we substituted into the parabola equation to get the values of y. So y is equals to 0 and x equals to 0, and y is equals to 0 when x is equals to 2. So having our intercept being equals to 0 and 0, and also have 2 and 0. So we're going to indicate, so this is a point where we have 0 and 0. And this is a point where we have 2 and 0. So these are our intercepts for this problem here. So for us to draw the function, we need also to identify the turning point of the function. So the g of prime of x is equals to, remember that the derivative, because our g of x is equals to x cubed minus 3x squared, when you derive, we got 3x squared minus 6x. And to find the turning point, we have to find x of t, which is equals to minus b over 2a, of which our b in this case is this minus 6 here. So it's going to be equals to minus into minus 6 divided by 2, and our a value is going to be this 3 here. 3, and you should get 1. So your x value of the turning point should be 1. And when you substitute that x value into this function here, g prime of x equals to 1, you should get a y value of minus 3. So your turning point of this function is 1 and minus 3. So we need to indicate them here. So when x is equals to 1, our y value is minus 3. So this would be the turning point of the function. Then we draw it, so it's going to look something like this. It's going to look something like this. So because this parabola here, it is a smiley face. Normally when you say it's a smiley face, it's when a value is greater than 0. Then you know it's smiling. But when a is less than 0, you know it is sad, right? So this one is a smiley face, meaning that it has a point of minimum. This is the minimum value of y, which is equals to minus 3, having the x value being equals to 1. So hence we can define the function as a point of minimum. So the point of minimum, it is when y is equals to minus 3. Now 8.3, hence or otherwise, determine 8.3.1, determine the values of x for which the graph of G is concave down. So when something is concave down, which means it's facing downwards, right? So it's when you have a parabola that is facing downwards. But if it's concave up, it is facing upwards, right? So please note it down. This is concave up. This is concave down. So in we normally call this convex, and this is just concave. So yeah, for concave down, we are focusing on this shape. So what we need to do here is we need to find the point of inflection. So the point of inflection, it helps you to interpret the concavity of your cubic function, right? So what you're going to do is this. We're going to write our g of x, which is equals to x cubed minus, so it's x cubed minus 3x squared, and find our points of inflection. So first derivative is 3x squared minus 6x. The second derivative is equals to 6x minus 6. So we have to first find the point of inflection. We equate to 0, then 0 is equals to 6x minus 6. Transpose the 6 to the other side, you have 6x equals to 6. Divide by 6 both sides, so therefore x is equals to 1. So this is the x value of the point of inflection, right? So we're going to use it to interpret the concavity. So what you're going to do is you're going to draw our function. Let's draw our function. We're not going to draw it to scale or draw it accordingly, but we know that here our g has a being greater than 0. So it's a is equals to 1, meaning the gradient is greater than 0. So when your cubic function has a gradient that is greater than 0, it means that it increases, decreases, and increases. So when a is greater than 0. But when a is less than 0, you'll have a cubic function that decreases, increases, decreases, right? So in this case, we are just looking for this one, which increases, decreases, and increases. So we have already identified the point of inflection being equals to 1 here. So meaning, let's say, for example, this is 1. This is not drawn accordingly, just so you know. So this is x equals to 1. So now, to identify the concavity of this function here, we are going to say, because we are looking for concave down, so for concave down, as I said, concave down looks like that. It's concave down. So if you look at this cubic function, which part is concave down? Definitely this part. This part is concave down. It's looking downwards. So meaning if x is equals to 1 here, so to interpret the x values when the function is concave down, you're going to say when x is less than 1, the function of g is concave down. So this is the solution that you're looking for, x being less than 1. So now 8.3.2 says that we must determine the gradient of the tangent to G at its point of inflection. So what we need to do here, we need to use the same value that we use for the point of inflection. We have already identified that the point of inflection x is equals to 1. And we want to identify the gradient of G. So the gradient of G, it is its derivative. So if G of x is equals to x cubed minus 3x as given, so its gradient is its derivative. So we derive this, we're going to get 3x squared minus 6x. So we're going to use this point of inflection to identify the gradient of this tangent. So we're going to say g prime when x is equals to 1 is equals to 3 into 1 squared minus 6 into 1. So you're going to have 3 minus 6, which is minus 3 here. So the gradient of this tangent is minus 3. We are going to do 8.4. So 8.4 says that determine the value of k if the graph of G is shifted so that the values of x for which the new graph, so there's a shift of the graph of G, and this is a shift, x plus k. So we are told that the shift causes the new graph to decrease in these points of -3 and -1. And we are asked to find the value of k when that happens. So the first thing we're going to do here, we're going to identify the gradient of the equation of g. So we know that g of x is equals to x cubed minus 3x squared, right? And we are told that there's a shift. So the shift is x plus k, right? So we want to find the value of k. We want to find this value of k here, right? So we are told that there's a decrease of p of x. It lies between -3 and -1. So the decrease lies between these 2 points, meaning that if we were to take a point, so it's going to be -2, because -2 lies between -3 and -1. So please take note of this. We're going to come at it later. So we need to first find the derivative of this function here to identify the value of x, right? So it's going to be, why am I identifying the value of x? So that it's going to be equated to this expression here. So to derive this, you're going to have 3x squared minus 6x. Remember that we are told that the gradient is decreasing. So if the gradient is decreasing, it means now that g prime of x must be less than 0, right? It's decreasing. So we're just going to write this expression here. So it's going to be 3x squared minus 6x less than 0. Then you factorize, it's going to have 3x into x minus 2 less than 0, like that. Then you find the critical values, which x is equals to 2, or this portion here, which is 3x being equals to 0. So divide by 3 both sides, so x is equals to 0. So these are your critical points. These are your critical points. Both of them are your critical points. So what you're going to do is this: you're going to draw your number line and write 0 there and write 2 there, and then you're going to test in your number line. You're going to test values before 0, which is maybe -1 or -2. You're going to test all those values. Even between 0 and 1, you're going to test it's 1, and after 2 comes 3 and 4. All those values you're going to test. Why are you testing? You want to identify the signs that lies between these numbers. So when you are done testing, if let's say for example you're going to test this value of x being equals to 1, so you're going to use your equation. Remember that your equation is this one here. It's this one here. So you're going to substitute x equals to 1, and the value that you find there, we are interested in the sign. So the answer you're going to get a positive solution, meaning that between 0 and 2 there's a positive solution of y there. And then before 0, you're going to test either -1 or -2. You're going to substitute them into this equation here. So when you substitute, you're going to find that you're getting negative solutions of y. So your answer will be negative, so meaning your negative solutions of y. You're going to do the same here, test 3 or test 4. In this equation here, you're going to substitute. Where there's x, you put 3 and put 3 and find the solution there. You're going to get a negative. So remember that in our problem, we are mostly... when you test your values, you will note that between 0 and 2, you're going to get a solution of negative. And then when you test any value between -1, -2, you're going to get a solution is positive, and here also you're going to get a solution which is positive. When you substitute these values here into your equation here, you're going to get these signs of y, right? So once you've done this, remember that this question says that find the values of x when the y value is less than 0. So this is where the y value is less than 0. So meaning that this means now that your x values lie between 0 and 2. So to conclude, you'll simply say your x value lies between 0 and 2. And remember that we're still not done. We want to find the value of k. Let's take this expression here, the shift. So there's a shift of x plus k, right? there's a shift of x plus k, and we are also told that the graph of p of x, decreases at these points here at between -3 and -2. So the p of x decreases at points between -3 and -1, right? So you're having all these conditions here. You have this condition, condition 1, and we have this condition 2 here. So what you're going to do is you're going to say x plus k is equals to what? It's equals to a solution, right? So what solution is that? You know that the function of p of x decreases between -3 and -1. So what is the value between -3 and -1? It is -2. So we are interested in this -2. So it means now that here, instead of writing x, you're going to write -2 plus your k value being equals to. So the solutions of x, remember that we are trying to find the solution of x here at this point here when we're dealing with our inequalities, and we found that our x value must lie between 0 and 2. So what is the value between 0 and 2? It's when x is equals to 1. You're going to say it's equals to 1. This expression is equals to 1. So you're going to transpose this -2 to the other side. You're going to have k is equals to 1 plus 2, which is equals to 3. So our k value is going to be equals to 3. So this is the solutions of k when there's a shift of x plus k. This is question 9. The statement says that the bracelet below, so this bracelet is beaded with is beaded by using 10 plastic spheres. So it consists of beads, as you can see there. There's 10 plastic spheres, so they are beads which are spherical, and there are 10 of them. And then we also have 10 beads which are cylindrical. So let's say this is a cylinder, so we also have 10 beads that are of cylinder in shape. So when completed, the bracelet will be painted. Ignore the holes in the spheres and cylinders. The following formulae are given. So this is the volume of the cylinder, and this is the volume of the spherical. This is a surface area of the spherical, and then this is the surface area of a cylinder, right? So the following essential properties of the beads are, so the radius is r of the sphere and the cylinder are the same. So the radius of the sphere and the radius of the cylinder are equal. The height of each cylinder is h. So height is h, so the height of the cylinder is h. 9.1. If the volume of cylinder is 6 centimeters cubed, write down h in terms of r. So we're talking of the cylinder, and we are told that the volume is equals to 6 centimeters cubed, the volume of a cylinder. But we know the formula for a volume of a cylinder is pi r squared h, and we are told that it's 6, so you need to write in terms of r. So it's going to be pi r squared h. You divide by pi r squared, divide by pi r squared. So our h is equal to 6 divided by pi r squared. So this is the height of the cylinder with respect to r. 9.2, we are told that show that the total surface area of all painted surfaces of the bracelet is equal to this expression here. So for us to show the required question, we need to add the entire surface area. So the surface area of a cylinder, we must edit the surface area of a sphere. So the surface area of a sphere, we need to edit the surface area of a cylinder. So what you're going to do is we're going to the surface area of a cylinder, it's 2 pi r squared plus 2 pi r h plus the surface area of a sphere, which is 4 pi r squared, right? So we're going to add like terms. So this is a like term of this one, so we'll add them together. So it's going to be 6 pi r squared plus 2 pi r h. Remember that h is given as 6 divided by pi r squared. This is an expression we found in 9.1. So we're going to substitute that expression. So it's going to be the surface area, the total surface area, being equals to, so you're going to write this expression, but instead of writing h here, we'll substitute it with this h here. So it's going to be 6 pi r squared plus 2 pi r. So where there's h, we'll put 6 over pi r squared, right? And then what we're going to get is 6 pi r squared plus, so the 6 multiplied by 2, it's going to give us 12 pi r, and then divide by pi r squared. So this pi goes away, r goes away. We have 6 pi r squared plus 12 divided by r, because this is r squared and this is r. And this is the total expression, but we need to remember that there's 10. So we should remember that there's 10 beads which are of cylinder shape, and there's 10 beads which are spherical. So we need to multiply the surface area by 10. So meaning the surface area is equal to 6 pi r squared plus 12 over r. You multiply everything by 10. Then what you're gonna get is the 6 multiplied by this part here. It's going to be 60 pi r squared plus the 10 multiplied by the 12 here. It's going to be 120 over r. So this is the expression of the total surface area. Now I'm going to do 9.3. 9.3 says that determine the value of r so that the least amount of paint will be used. So to determine this value of r so that the least amount of paint is used, we need to use our surface area, our total surface area, which is equal to 60 pi r squared plus 120 over r. So to find the value of r such that least paint is used, we need to find the derivative of this expression here. So S of r is equals to 60 pi r squared plus, we take the r to the top, it's going to be 120 r to the power minus 1, and to find the derivative of this expression, the 2 goes down, so it's going to be 2 times 60 pi r to the power of 2 minus 1. The minus 1 goes down, we have minus 120 r to the power minus 2. So our derivative is going to give us 120 pi r to the power of 1 minus 120 r to the power of, because there's minus 1 here, remember that it was minus 1, sorry, it's minus 2, because here it was minus 1 gives us minus 2, so it's going to be to the power of minus 2. Right, so this is the derivative of r, but it's derivative of the expression, rather, the surface area, the derivative, and then we're going to equate the derivative to 0 because we are looking for r. So 0 is equals to 120 pi r minus 120 r to the power minus 2. So you're going to divide by 120 r, divide by 120 r, divide by 120 r. So what's going to happen is you have 0 here is equals to pi minus r to the power of, because this is r to the power of 1, if you take it up, it's going to be r to the power of minus 1. So you're going to have r to the power of minus 3, because it's the same base, they add exponents. So this goes away, and then you are left with this. So r to the power of minus 3 is equals to pi. And to remove this to the power of minus 3, we have to multiply by negative 1 over 3, multiply by negative 1 over 3. So our r is equals to pi to the power of negative 1 over 3, which if you write it properly, it's going to be r is equals to 1 over pi to the power of 1 over 3, which approximates to 0.68 centimeters. So this is question 10. We are given events A, B, and C, and we are told that event A and B are independent. So when event A is independent to event B, which means when you multiply the probability of A and B, it must give you the intersection of A and B. So so this is what we are given here, probability of A and B and the intersection of A and B, and they're also given the complement, which, oh sorry, we're also given the probability of C because we have probability of C. So 10.1, are event A and B mutually exclusive events? So mutually exclusive events have an intersection of A and B being equals to 0. So here you really don't have to do much. You can simply say since probability of A and B are not equal to 0. Why am I saying they're not equal to 0? There it is. We already have the intersection. There it is. Probability of A and B. If you have this, it means and in probability. If you have this, it means union. Right? So we already have the probability of A and B, and it's 0.1596. So because it's not equal to 0, therefore not mutually exclusive. Fine. So we are done with 10.1, and 10.2, by using an appropriate formula, show that the value of P of A union B is equal to 0.64. So we want to identify the union of A and B now. We already have the intersection. So for us to determine that, we're going to say the P of A union B is equal to the probability of A plus the probability of B minus the probability of A and B. All right, so the probability of A is equal to 0.38 plus the probability of B, which is equal to 0.42, minus the probability of A and B is equal to 0.1596. So when you add everything together, you're going to get 0.6404, which approximates to 0.64. So this is the union of probability of A and B, which we've already proven. Which fine. 10.3, calculate the number of people in the sample space. So now I want you to take a look at the information given. We are given the probability of A, we are given the probability of B, we are given the probability of A and B, we are given the probability of C. So to find the union, or to find the sample space which is N of S, to find the sample space of N of S, we need to know the number of the sample, the number of sample. So in this case, we're not given the number of the sample. The question doesn't have N of the sample. So because we are looking at the number of people in the sample space combined. So let's say, for example, you have your diagram. Let me draw the diagram. So let me erase this. So if you have something like this, your Venn diagram, and this is your event A, and this is your event B, and you're told that they're independent, which means they have the intersection, and then you have event C like that. So for us, we need to identify the number of, let me check the question, the number of people in the sample space. So we need to identify the number of people that exist in a total of event A, B, and C, and those that exist here. So the sample space is the entire thing here, sample space. So the formula of a sample space is written as follows. P of whatever event, let's say P of E is equals to N of E over N of S. So if, let's say, for example, we are focusing on event A, it means that we need to know the number that exists in the sample of A to be able to find the sample space. We know this. We know the probability of A, which is equal to 0.38. But we don't know N of A. We don't know N of A. The number of ways that this event happens. We don't know N of A. So it's not known. Hence, we cannot identify the number of samples. If, let's say, for example, we were told, because we are looking for this guy here, the number of samples, we would cross multiply and say N of S multiplied by P of A is equals to N of A, right? And to find N of S, we divide by P of A, meaning N of S is equals to N of A divided by P of A. So this is how we would find the sample space of this problem here. But since we don't know this problem here, we don't know the value of N of A, but we know this one, so we cannot identify the number of the sample space. It cannot be identified if this N of A is not known. So 10.4, we are asked to find N of complement C, right? So the complement of C, which is the C that we were given here. So for us to find that, we're going to do this. We already know the probability of C, right? The probability of C is given as 0.28, and P of the complement of C is going to be equals to 1 minus P of C, right? So it's going to be 1 minus 0.28. So this basically means P not C, right? So the answer you're going to get here is 0.72. So this is P of C naught, right? And so this is P naught of C. Let me write there, P naught C. Cool. So for us to find N of C naught, it's going to be equals to P of C naught multiplied by N of S. So for us to find this value here, the number of C naught, we need to also have the sample space. So already we have 0.72 for P naught of C, right? So we need to have the number of the sample space for us to complete this problem here, because in 10.3 the N of A was not given, hence we cannot identify the sample space here. So you can leave the question here, not unless there's something missing in that question which was rectified during the exam. So but this is how you go about solving this problem here. If you have any questions regarding this problem, please write down in the comment section below, or any suggestion, you are welcome to comment. Okay, so question 11.1, each of the digits, we have 1, 1, we have 2, 3, 4, and 7 are written on a separate card. The cards are then placed next to each other to create a 6-digit symbol. So yes, 6-digit number. 11.1.1. How many numbers start and end with the same digit? How many numbers start? So we're having let me just write it here. we're having 1, 1, 2, 3, 4, and 7. So these are the numbers that we have. And we are asked how many numbers start and end with this. And we are asked how many numbers start and end with the same number. So this is what we have here. 1, 1, 2, 3, 4, and 7. And we are asked how many numbers start and end with the same digit. And we are told that these numbers, let's say they are placed on a card separately, something like this. So let's say, for example, this is 1, this is 1, this is 2, this is 3, this is 4, this is 7. And we are asked how many numbers are placed next to each other having the same digit. And we are asked how many numbers have the same digit from start to end, right? So to solve this problem here, because the question says that we want the number of numbers that start and end with the same digit. So don't confuse same digit with identical digit. So we can simply say, if we say 1, this number here is the same as 1, this number here. If we say this card is the same as this card, right? And we assume that the card of 1 and the other card of 1 are identical. They are identical. You know, when you talk of identical, you think of twins. Because you can have a human body, 2 human bodies, but those bodies are not identical, right? So let's assume that these 2 human bodies, or these 2 cards rather, are identical. So if we assume that they're identical, so meaning that by redrawing these cards here that I drew on top, we're going to say 1, we start with 1, and then in between it's going to be these numbers here, all these numbers. So it's going to be your 2, your 3, your 4, your 7, and then we're going to end with 1. So we start with the number 1, we end with number 1, and we consider them identical. And then in between is going to be 2, 3, 4, and 7. So what's going to happen is, if we consider the first and last, if we consider this to be identical to this, then it's going to be 1 factorial. It's just simply going to be 1 multiplied by, so what happens in between is going to be different, right? So meaning these cards are different. 2, 3, 4, 7 cards are different from each other. So there are 4. We have 4 cards, right? So meaning it's going to be 4 factorial multiplied by the 1, because we consider it to be the same as the other one and they're identical. So you're going to have 1 multiplied by 4 factorial multiplied by 1, which you'll have 4 factorial as your answer, which is going to be 24 ways. So this is how you're going to solve this problem here. Now, 11.1.2 says that find the probability that the number is 1, 1, 2, 3, 4, 7 or 7, 4, 3, 2, 1, 1. So we need to identify the probability of this happening. So if we said, as we said, that the number 1, or the card which has 1 inside, and another card which has 1 inside, if you consider them to be identical, this is how we're going to find the probability. We're going to say the probability of these two numbers happening is going to be equals to the factorial of 6. Why am I saying the factorial of 6? You're going to count your digits. So it's going to be 1, 1, which is 2, 3, 4, 5, 6. So all these numbers combined, they are actually 6. So that's why you're going to say 6 factorial divided by 2 factorial. So the 2 factorial is for these two cards here, which we consider to be identical, right? So you're going to get your answer here, which is 360. And then the probability will be equals to, because these two was for identical cards. Now let's find the probability of the non-identical cards. Okay, so because we're looking at identical cards, we're going to say, how many identical cards do we have? We have 2 divided by the 360, which will give us 1 over 180. So this is the probability of these two happening here. Now, 11.2 says that n people, 1, 2, 3, 4, 5, 6, up to n, are arranged randomly in a line. So let's say you have people, you have this person here smiling, another person here maybe frowning, another person here. So they are arranged in a line, they are standing on a queue, whatever, randomly. So find the number of ways in terms of n such that person 1 and person 2 are standing next to each other. So if we consider this to be person 1 and we consider this to be person 2, we must find the number of ways in which these people are going to be standing next to each other. So how do we identify that? So what we can do is to find the number of ways in which they are standing next to each other, we're going to use 2 factorial because we're looking at person 1 and person 2. So that's 2 factorial. And the total number of people, it's n, right? Because when you say n plus 1, you are going to the next person, right? It's next. Like if you think of it in terms of your sequence and series, right? If you say s is equal, so if you say n minus 1, you are basically talking of the previous person, So this is the next person, this is the previous person. So we're going to take this n minus 1, meaning that we are going backwards, so meaning the next person. So this is the forward person, and we say minus 1 because you consider the previous person. So the answer here is going to be 2 factorial into n minus 1 factorial. So that is the solution, the number of ways in which person 1 and person 2 will be standing next to each other. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.